Hello everyone, my name is Helen Pham and this is going to be my 5th blog for Informatics 655 titled Software Development Lifecycle Methodologies. Before I begin talking about SDLC methodologies, I wanted to define what SDLC is. It's also known as Software Development Lifecycle, considered to be a series of phases for software development and management. It involves every step of the software creation to implementation, and that includes planning, analyzing, designing, building, testing, deploying, and maintaining. It's important to determine the most appropriate SDLC model to ensure that the organization is successful in their project. So what is SDLC methodology? It's considered to be models specific to requirements and goals of the project. It's a tool to better deliver software projects. And so knowing and understanding each model and when to use them allows us to see the advantages and disadvantages of each model that is suitable for the project. So here I've listed 5 of the SDLC methodologies that I found were most common, and then there were several ones that I saw but I didn't include in here. But these are the ones I'll be talking about mostly in this presentation. And so as previously mentioned, there are several software development lifecycle methodologies, and that includes Agile, Lean, Waterfall, iterative, spiral, Vshape models. So these projects are different in their own unique way, but they do have a similar goal of allowing project teams the ability to deliver quality software timely and cost effectively. The first one I'll be talking about is Waterfall, and it is a sequential flow, kind of downward like a waterfall through the software implementation phases. And so it's an earlier approach, and it's most widely known in the software development field. The steps involved are requirements, then it goes to data and design, and then it goes to implementation, and then it goes to verification and maintenance. It's most useful for projects that are not focused on changing the requirements, which is why it's so structured and rigid. And due to the little flexibility and adjusting scope of the model, it can be difficult and expensive. And so I've listed here the advantages and disadvantages of the waterfall model. We can see that the advantages may include it's easy to understand because it's just step by step. It's very structured, so it's very organized. It assists in planning and scheduling. One step has to be approved before it actually moves on to the next step. However, there are disadvantages, including the difficulty of not being able to go back to the previous stage because it's a waterfall model, so you can't go back to requirements after you've already achieved designing. And it can be costly and requires more time input. The second one I'll be talking about is Agile, and this has been around for about a decade. It recently became a major driving force behind software development in many organizations. And so the requirements and solutions evolve as the multidisciplinary teams collaborate, and that includes the customers and the vendors themselves. And so different Agile testing methods include Scrum, Crystal, dynamic software development methods are just a few to name. And I've listed the steps here, so the requirements, design, construction, iteration, testing, quality assurance, deployment, and feedback. And so it looks kind of similar to Waterfall, but this one actually has iterations and where you can actually group the processes and then move on to the next one. So like, let's say requirements and design were grouped together, and then the teams respectively work on those projects together, and then they move on to the next one. And so advantages for this one is that it's timely determined, more communication is involved, so that's good. Higher quality with ensured customer satisfaction because once they figure out a mistake, they'll work together on it as a team. And disadvantages would be trial and error, documentations may be lost, and the final results may be completely different because changes occur, unlike the waterfall one where it's just constant. You stick with the project plan, you stick with that. In this one, you can make changes after they've discovered some feedbacks throughout the process. And it's basically you plan for the goals of the project based on the customer's view, then you build the experiment with the features that your customers are looking for, you launch your service and then determine the necessary changes, and then you repeat that cycle and add any additional changes or features. It's basically repetition and iteration to determine what changes and what modifications will be needed for the project to be successful. The third one I'm going to talk about is iterative, and this is effective for a large software application. It starts with determined requirements to develop the first version of the software, and then after that the version changes or new iterations can be made and another release can be made. And so the steps involved in iterative are requirement design, testing, implementation, deployment, review, and maintenance. And so that could be one iteration, that could be the first one. The second iteration could be design, testing, implementation, and then review. So it branches off review from the first one, and it just continues with design, testing, implementation, and review to determine if there needs to be any changes made to the project before it is finalized. And so advantages for this one is smaller iterations make testing and debugging easier, so they can determine what mistakes are found in the project earlier. Risks can be earlier detected and lots of time on designing. The disadvantages include not preferred for smaller projects. Its constant changing can cause over budgeting, and then completion date may vary because of the different changes that occur. Fourth one's going to be spiral, and this is preferred for organization projects that don't know the requirements or expect many edits that may experience mid to high risk. And so this is preferred for larger projects, unclear requirements, frequent modification, and higher budget projects. And so in Spiral, you determine your objective, you identify and resolve risk, you develop and test, and then you plan the next iteration. And so advantages for this model would be extensive risk analysis, software produced earlier in the SDLC. Disadvantage may be it's costly. Risk analysis may require experienced individuals, so as we've known that risk management and risk identification is very important for a project's success, so having the right individuals who have the experience and skills to determine those will be helpful. And it's not very good for smaller projects, so these are more for larger projects. And then last but not least, I wanted to talk about the Vshape. And so in this one, Vshape just refers to the shape that the steps make when they are put together. And so it includes verification and validation. It's sequential, so it's similar to the waterfall model, and it's shaped like a V with the step flows. Verification just refers to evaluation of the product development process to determine the requirements for the project. And then validation is process to determine if the product meets the customer's expectations and requirements. So one step must be completed before the next can proceed, so that's what it means when we say sequential. And it involves the steps of developer's life cycle, the verification phase, the validation phase, and then the tester's life cycle. And the advantages for V-shaped is that it requires a lot of planning. So that's good to determine what is necessary for the project. It's time efficient, it's effective for small plans with determined requirements. So this one's a very good one for small plans, unlike the other ones that were more geared towards larger plans. And then advantages would include it's very rigid structure because it's very sequential, so one step to another. It's not good for complex project, and there are no early prototypes because once the software is produced, it just continues to advance from there. So it's not actually a prototype. They actually make the software and determine what to change from there. And these are my references. So there were a few I didn't talk about, including Big Bang model, prototype model, and rapid application develop model, but those are definitely reviewed in my resources here. Thank you.